Hello everyone, myself Sindhu. So today we are going to discuss about a research paper titled Big Data Analytics for Earth Science, the EarthServer approach. Now in this slide we'll introduce the topic of the presentation and it includes a paper title, authors, journals, publication date and when it was issued. So the title of this research paper is Big Data Analytics for Earth Science, and the authors are there are so many authors. Among them, I would like to mention only three of them, that is Peter Boomem, Palo Mazzetti, and in the journal where the paper is published is International Journal of Digital Earth, and it was published on 2nd March 2015. So at first let me begin with the introduction to the big data in earth science. So how big data is like useful or how it is applied in the earth science. So basically we define big data in three ways. It is three ways, that is volume, velocity, variety. So as we all know, volume includes a huge data size. So basically what data is, it is a collection of information. Whether it is useful or not useful, it's secondary, but what basically data is, it is a collection of information, and volume represents a large amount of data, or a huge amount of data. Next comes velocity. So how we process the data and how fast we process the data, and how speed it is, how speed the data is processed and the output is generated will be included or will be defined in velocity. Next is variety. Variety in the sense it is different types of data, whether there are so many types of data, for example text, photos, videos, audios, written document, excel, these type of, there are lots of different datas. So basically big data includes all these three values, that is volume, velocity, variety. And so this velocity is the need for the real-time data processing. Variety, there are, that is heterogeneity in data sources and formats. So earth science data is characterized by large multidimensional data sets from various sources, satellites, sensors, etc. So now how this big data is applied or it is applicable to the earth science. This will For this we'll collect the data from variety of sources. There are multi-dimensional data sets, not only a single source for to collect the data, the variety of sources. So one such among this is a satellite data, so where the satellite collects lots of data from the data, like what you're using in the phone and other surroundings, what environment, in this environment we are facing. So all this data will be collected and it is applied in the earth science. So basically earth science means, so anything which is related to earth is called earth science. So in this paper, the challenges include heterogeneity in data formats, a large volume of observations, and a simulation requiring advanced processing technique. So in while publishing this paper, the major challenges was for the researcher is to include the heterogeneity in data formats and a large volume of observation. So in order to, like as we say, earth sense is not a small part. It is it covers lot of areas and lot of regions. So we have to observe each and everything, and we have to collect data from multiple sources, not from only the single sources. So the collection of those data and observing those data was such as a challenging task while publishing this paper, and the simulations requiring for advanced processing techniques. So once we have collected the data, somehow we have collected, once we have collected it, and we have to pre-process, because if the data is not pre-processed and if it is not in the structured way, the readers cannot understand how, what data is and what is the information that data is giving to us. So once we have collected the data, it's the pre-processing is a major technique. Next we'll go to the project overview, and what is the overview of this papers of this paper. So this paper aimed at to create a big data analytics engine tailored for earth science, and it is funded by European Union 7 Framework Program collaborations among European research institutions and NASA to provide open access to the Earth science data. Development of scalable system to handle large geospatial datasets, example satellites, images, and climate data. So, in this project, what is the overview of this project is the European funded initiative aimed at creating a big data analytics engine specified for the earth science. So Europeans is a funder and they aimed at creating a big data analytics in the earth science field. It highlights the collaborations between the European research institutions and a NASA. So this project highlights what's the it is collaboration between the European research institutions and NASA. And this project's keys goal is to provide open access to the massive geospatial datasets and support efficient analytics. So this slide sets the stages for the technical solutions that EarthServer provides, focusing on the scalability and ease of data handling. So shown diagram in the list, diagram that is shown in the slide is how the component diagram of Earth Data Server. So how data services, how data is collected, and the process of data. So technologies in Earth server. The major technologies were the RASMAN, an array database optimized for multidimensional data, and OGC standards. It is a web convergence services for multidimensional raster data, web conventional processing services for real-time analysis. Razdman supports large-scale storage and retrieval of spatiotemporal datasets, including satellite images and environmental models. And the standardizations. Interoperability ensures the adoption of the open geospatial consortium to the standards. So, major technologies used in this project is RASMAN and OGC standards, and how RASMAN supports for the large scale storages and the retrieval of the spatiotemporal datasets and the standardizations. So here the focus is on the core technologies used for the uh, Earth server projects. The RASMAN array data bed is a design for the handling multidimensional data like satellites, images, and climate models. It supports the open geospatial consortium standards. So Web Convergence Services, that is WVC, handles the multidimensional raster data, and Web Converged Processing Services, that is WCPS, provides a real-time analysis capabilities. So here what these technologies will emphasize how RASMAN help in managing a large scale data and performing complex queries efficiently. So the next here we are going to discuss about the lighthouse application, which is prescribed or defined in that research paper, how it is applied, like how with the help of what we have collected the data. So developed developed to demonstrate Earth service capabilities in real world scenarios. Marine services track ocean color changes using 15 years of satellite data. Geology services provides access to 3D geological models and Landsat data for better understanding of geological formations. And atmospheric and climate services time series analysis of pollutants and meteorological fields. Christopheric services monitors snow cover and calculates water equivalent over large areas. So majorly how this lighthouse application, so what are the applications from the project, what they have done, and how it is applied to the real world. So major services provided by this project is marine services, geology services, atmospheric and climate services, and cryptographic services. So this is the images which I have collected from the paper what I have mentioned above. So the first the picture says about, or it describes about the 3D web client configured to display the data from two sources. So here the data source, like data is displayed from two sources, that is DM and point cloud in shared scene. And the figure 4, it's it says Earth server marine services. So what we have mentioned above service, what it is applicable. Band ratio client provides a simple user interface to generate a complex algorithms for teaching and testing new ideas. Then the application, this lighthouse application shows the Earth server's ability to handle the large datasets across different Earth science domains. Then big data analytics challenge. First, we have discussed about challenges faced by the researcher while completing this project. Now we're gonna discuss about big data analytics challenges. So what are the challenges which is related to this big data and how they overcome these challenges and what is the output which we have got. So, specific challenges in earth science include handling heterogeneity of data, that is, in situ remote sensing simulations, and volume of earth observation data growing rapidly, complex processing needs for real time analysis, and need for the system that can efficiently integrate, analyze, and visualize the diverse data. So, the basic challenge or the most like where challenges which is faced by them is handling the heterogeneity of data. So heterogeneity means not only a single type of, there will be multiple types of data. So if that the data there is a similar type, then it is called a homogeneity data. If the data which is multiple or the different, such as text, audio, video, excel, some of the analogous data, so all this mixed together, then we'll say it as a heterogeneity data. And handling that heterogeneity data was very a challenges thing for the researchers. And the volume of earth observation data growing. So as we all know, sorry, as we all know, volume of the earth, like if there is a lot of data, for example, let us take our example. If we have a 10 data, so we can easily analyze and we can say, oh okay, these numbers. So if we have 100 thousands of data, even it takes time to us to remember what the data is and how to organize that everything. So um, to analyze and to understand those observations for challenges thing. Next comes the complexity. So the need for the fast processing to handle real-time queries, it also touches on the need for flexible, efficient systems that can handle diverse data and complex queries. So this is the picture what I have collected from the paper, that is Earth server atmospheric services, aerosols, and how it is service provided. Next, let us discuss about the scalability and performance. So, achieved through how they have achieved the scalability through array partitioning for the faster data access, multi-core and multi-node parallel processing, performance improved by the optimizing query executions for the complex analytics, intra-query and inter-query parallelization demonstrated near linear performance improvements. Next, visualization and access. There are different types of visualization, not only one single type. So we can visualize the data as a text format or in the graphs, or in graphs there are different types of visualizations, not only histograms and then bar graph, pie chart. There are so many types of graphs. So how the data is visualized and how it is helpful for the viewers to understand the data. So user-friendly visualization tools for earth science data are 2D and 3D visualizations for accessing and exploring data interactively. For example, Marine Service provides a 3D viewer for exploring ocean data over time. Then mobile apps. EarthServer provides a mobile app for quick access to the data. So this is the snapshots of all those, how the data is shown and from where the data is collected. Next, we'll discuss about the standardizations and interoperability. So, key to ensure that the data from the diverse sources can be seamlessly integrated. So, Earth Server supports the OGC converged data and service models. GMLC GMLCOV, that is Geographic Markup Language Coverages, allows representations of multidimensional datasets. Interoperability across systems, enabling researchers to query datasets from different regions and sources easily. At last, now I'll conclude my presentation or my uh, video. So what and all we have discussed is EarthServer successfully demonstrated big data analytics for earth science and significant impact on real-time data analysis, open access to geospatial datasets and standardization efforts. The platform's scalability and interpretability make it as a strong foundation for the future developments in earth science research and data analytics. So thank you.